Hello and welcome to Regrowtech India. I'm your host, Turin Nayab, bringing to you yet another episode of the Java Beginners Interview Series. Now, in today's episode, we are going to discuss about what an Armstrong number is, and we will discuss what Java concepts can be applied to check whether a number is Armstrong or not. So the end result is to be able to write a code to check whether a number is an Armstrong or not and to understand the dry run of the entire program. Now, let us first understand what kind of number is termed as Armstrong, and then we will try to understand the logic behind it. So let's get on the whiteboard and check out the question. So it says, write a program to check whether a number is Armstrong or not. An Armstrong number is a number whose sum of digit raised to the power of the number, raised to the power of number of digits is the number itself. Okay, meaning, let us say the number is 1, let's say the number is 12. The number of digits on the number 12 is 2. So each of these digits should be raised to the power of 2 and then added. And if it is same as 12, then the number is Armstrong. A popular Armstrong number is also 153. Now 153 has 3 digits. So each of these digits raised to the power of 3 and then added should give us 153 in order for this number to be Armstrong. Now one important concept is raising a number to a certain power. So for that we will use math.pow function. Math.pow or math.power function will help us to calculate the power of a number raised to whatever power we want, because it takes two parameters. One is the base number, second one is the exponent itself. For example, if we write 2 comma 3, it means we want 2 to the power of 3, where 2 is the base number and 3 is the exponent. The value it will return as 8, or rather 8.0, because the value returned by math.pow is always a double value, which is why it is going to be a decimal number, right? This is one concept. Now, let us understand a little breakup of how we are going to write the code for Armstrong number here. So what we are going to do is, first of all, because we need the number of digits, that's how we will raise the numbers to the power of number of digits, right? So first of all, we will first write a small code to get the number of digits, right? Once we have gotten these number of digits, we will then use that to write another code to get the sum of the values raised to the number of digits. Okay. Now we'll go ahead and write our first bit of program to find the number of digits first. So we will go here to the Eclipse. Okay, so first of all, what we are going to do is we are going to go ahead and take our number. Let us say I take a random number, int n is equals to 1, 2, 3, 4, just to have an understanding. And we'll use a while loop. While n is greater than 0, then we basically want a variable in which we will count the number of digits, right? So let's say int d for digits is equals to 0. So we will say while n is greater than 0, then add d plus plus, and then in order to continue with the while loop, n is equals to n divided by 10. And if I print d, it should give us the number of digits. So system.out.println number, oh my god, number of digits is d. So we'll simply save it and run it. Number of digits is 4. Let's check out for 153, because that is what we want to check it against eventually. 153, the number of digits is 3. Here, let us understand what happened. So all we did was, let us go back to the whiteboard to understand a quick try run for this, so that we don't have to understand the entire program in one go. So we'll go to the whiteboard here we are. Okay, now see, all we have is simply n is equals to 153. So n is equals to 153. Next up, we will have d is equals to 0, digits is d is equals to 0. Next, we will have while n is greater than 0. So n is greater than 0, yes it is d plus plus. So 0 plus 1 is 1. N is equals to n divided by 10. So 153 divided by 10 will give you 15. Next time it will go back to the top. Again, n greater than 0. 15 is greater than 0. Yes, it will go inside. It will again do d plus plus. So digit plus plus. Right now digit is 1 plus 1 plus 1 is 2. Next, n is equals to n divided by 10. So again, 15 divided by 10, we will be left with 1. Again, it will go back on the top. 1 is greater than 0. Yes, it is. N is greater than 0. That is true. Again, it will go inside. D is equals to D plus plus. D plus 1. Meaning 2 plus 1 will become 3. Number of digits is 3 right now. Again, n is equals to n divided by 10. So 1 will become 0. So n will become 0. Again, the condition will be checked. 0 is greater than 0. No, it is not. So it will not go inside, and the last value of d will be considered, which is 3. So therefore, when it will print system.out.println number of digits plus d, which is 3. That is the reason why we got 3 as the number of digits. Okay, now that we have found out the number of digits, we can actually use this for the rest of the Armstrong number code. So let's go back to Eclipse and write another piece of code. Now, before we do anything else, I want to simply print one more thing, which is the value of n. So n, if you see here, is not 153 anymore. It is 0. Okay. The reason as to why it becomes 0 is because it is getting updated in the while loop, right? So now if we want to use the value of n again, the number 153 again, we will have to store the value of n in some other variable as well. So for our convenience, we will say int n1 is equals to n, and then we will write our code based on n1 instead of n. Now we basically want to take out one digit, raise it to the power of digits, and then add them. So first of all, we will take a variable int sum is equals to 0 for now. Then we will go ahead and write while n1 is greater than 0. Then in that case, what I will do is, first of all, I will take out the last digit, because I can't take out from the first digit. I will always take out from the last digit. It doesn't really matter, right? Because whether I am taking out from the last digit or the first digit, I want to pick out one digit, raise it to the power of digit, and add them. That is exactly what will happen here also. So I'll take int ld is equals to n1 mod 10. First of all, then n1 is equals to n1 divided by 10. These two lines we have already seen multiple times that this will remain constant no matter what. After that, we will see. So first of all, we will have to take another variable in which we will store the power value. And we know that the return type of math.pow will be double. That is why we are storing it in a double variable. So double p is equals to math.pow, and the power of last digit raised to the power of d digits, number of digits, right? So once that is sorted, we will do sum is equals to, and I will write int here because I need to do a little typecasting, because I want to do sum plus p, right? And I will put this under a separate round bracket. Okay. So what I did here is my p value wasn't double. I wanted to add p with sum. Sum here is integer. I can't do that. I can't add two numbers which belong to different data types. So what I did was I typecasted the entire thing to integer so that it will not give me an error. Okay. So once I have done this, I can, for now I want to first print the sum. So let us print the sum. The sum is 153. Okay, I do not want to print the number of digits. So let me just, oh no. What happened? Oh, I selected everything. So we'll just select this one, move this away. And next, I want to check the sum. It should be equals to the original number. Now, original number was the variable n, but then the value was changing. So we stored it in n1. But n1 value will also change now, because eventually here n1 is also being used in a while loop. So what we will do is we'll make another copy of n. Let's say n2 is equals to n. Okay, here instead of checking sum is equals to n, we will check it with n2, because n and n1 both of their values has been changed already. So we'll check if n2 is equals to sum, then print system.out.println Armstrong number else not an Armstrong number, and that is that. Okay, so we have already understood how to take out the number of digits. Now we need to simply understand this part. So here what we are doing is we are taking out one digit and we are updating n1 so that the next time it goes, it can continue the while. Then we are taking last digit to the power of d, which is 3, right? So for example, the last digit will be 3, 3 to the power of 3 will be 9. So 9 plus 0 will be 9, and that's how the sum will be calculated. We will see a quick dry run, but first let us see whether this number is Armstrong or not. And yes, it is. Okay, so let us go ahead and copy the entire code to check and see how the dry run looks like. So here we are. Let's go to the whiteboard. Let's paste the program here first. Okay. Now, first of all, we have understood half of it. We'll understand just the rest. So here we go. We already have what all variables and their values are there. Let's write it down. So n is 153. n1 will also be 153. n2 will also be 153. Later on, after this, n will become 0. After this, n1 will also become 0. Okay, we will see about that. Sum is also 0, so sum is equals to 0. Digit, here we will get 3. Okay, so d is 3. Next, here what is happening is while n1 is greater than 0, so let us write n1 here. n1 is 153. Okay, so while n1 is greater than 0, n1 is 153, it is greater than 0, it will go inside the while loop and it will check LD is equals to n1 mod 10. n1 mod 10 meaning LD mein first value will be 3. Next, n1 is equals to n1 divided by 10. 153 will become only 15. Next, P will be math.pow LD comma D. D we know number of digits is 3. So P will be 3 to the power of 3, which is 27. Okay, once that is sorted, we will see sum is equals to sum plus P. So there is another variable sum is equals to sum. So firstly, sum was 0 earlier, as you can see here. So 0 plus P, which is 27. 27 will come in the sum right now. Next, what will happen is we will go back to the loop again. So again, it will go back to the top. It will check while n1 is greater than 0. n1 right now is 15. It is most certainly greater than 0. So it will go inside. Again, it will calculate LD. LD is n1 divided mod 10. So 15 mod 10, you will get 5. Next, n1 is equals to n1 divided by 10. 15 divided by 10, you will get the quotient as 1 because remainder was 5. So here what we are going to do is we are again going to calculate P. P now will become LD. LD has 5 to the power of 3. So 5 to the power of 3, we will get 125. Okay, so now the new value of P is 125. Sum is equals to sum plus P. So sum will become 27 was there, sum plus p now is 125, 27 plus 125, 152 you will get, sorry 52, okay. Next, it will go back on the top, it will check n1 is greater than 0. Yes, it is greater than 0. 1 is greater than 0. So again, it will go inside, take out the LD. LD will also become 1. Now, 1 to the power of 1 to the power of 3 is still 1. Then again, it will be added 152 plus 1 is 153. So now sum has 153. It will check with n2. And n2 we have checked. n2 is also 153. So sum is equals to n2. If they are equal, then Armstrong, otherwise not an Armstrong. Okay, that is simply the dry run of this particular program. I hope it is well understood. If you did not understand, I urge you to watch this video again, because this is a little complicated code, or this is a little complicated version of Armstrong, or rather while loops, right? So please check it out again. If you have any other programs in mind that you would want us to take up, you can always post them on the comment section. If you like the video, hit the like button and subscribe. Have a great day ahead.